In this video, we're going to talk about quadratic equations and the different ways we can solve them. So what is a quadratic equation? A quadratic equation is simply an equation where the highest exponent on the variable is 2. Oh, there's no example. Let's go ahead and write one down. So for example, we could have 0 equals x squared. We could also have 5x squared minus 7 equals 2x. These are both examples of a quadratic equation. Now the value or values make the equation two are known as solutions. This is no different from when we had linears. However, what is different is that we could have two solutions, or one solution, or no solution. Now, there are 4 different ways we can solve a quadratic equation. At least ones that are most common. There is a zero factor law, square root method, complete the square, and quadratic formula. We will be focusing on the zero factor law and quadratic formula. The zero factor law simply states we'll be using the zero factor law if you're using factorization. We use factorization to find solutions. If a times b is 0, then that means that a equals 0 or b equals 0. What we can do is we can use this and the fact that if we have a product equaling 0, then that means one of the factors must be 0. Let's go ahead and look at 3x squared plus 8x plus 4. Let's go ahead and first factor this. Whether you use trial and error or the AC method or any of the other methods that are out there, you're going to find the factorization. 3x and x, and then we're going to have plus 2 and plus 2. We can verify this by writing it down as 3 times, oh, that's not right. Oops, hold on. Oh, did I mess up this one? Oh no. 3x, 2 and 2. Oh no, that was right. Because we got 6 plus 2 is 8. Perfect. Okay, my apologies. So now that we have the factorization of our quadratic, we can now use the zero factor law. The zero factor law states that if I have a product equaling 0, then that means one of the factors must be 0. Here, I have two factors multiplied together to give me a product of 0. Then by the zero factor law, we get as follows. Either 3x plus 2 is 0, or x plus 2 is 0. By solving each individual equation, we get that x is either negative 2/3 or x is negative 2. So what we have is we have two solutions, where one solution is negative 2/3 and the other solution is negative 2. That means there are two values that will make this equation true. And that's how we use the zero factor law. Once we have the factorization, we set each factor to 0, and therefore we solve each individual equation, and we get our answer. The second one we're going to talk about is the quadratic formula. This is a particular formula that's used to solve any quadratic equation. We use the quadratic equation for any quadratic. However, if it's not factorable, we're required to use the quadratic formula. So let's go ahead and try this problem. We're going to find the solutions to 6x squared minus 9x equals 14. Now we have to make sure that the equation, the quadratic equation, is in the form of ax squared plus bx plus c equals 0. Since we don't have 0 on one side of the equation, we're going to first manipulate the equation so that it does. In other words, I'm going to subtract 14 on both sides. Now we're going to go ahead and use the quadratic formula. Let's pick out our numbers. A is equal to 6, B equals negative 9, and C equals negative 14. Please note that the negative sign that's in the equation goes with the coefficient. So now if I use the quadratic formula, I'm going to type, and I'm going to replace my values as follows. I'm going to do negative of negative 9, since that's B. I'm going to do plus or minus the square root of negative 9 squared minus 4 times a, which is 6, times b, which is negative 14. And we're going to divide that entire thing by 2 times 6. By doing some quick calculations, we'll find that we'll get 1 minus 4 times 6 times negative 14. We're going to get 9 plus or minus the square root of 417 all over 12. Now, 417 is not a perfect square. You're not going to be able to find it. Now, 4 plus 1 plus 7 is 12, so there's a factor of 3. But that's not a perfect square, so we can't factor that either. So in reality, this would be the simplified answer to our problem. Now you might be wondering, how come there's only one answer? But in reality, there's actually two. The plus and the minus give two different answers. We're going to add the square root of 14 to one side, and then we'll subtract the square root of 417 from 9, and then divide that by 12. This gives us the two answers right there. But if we do not have to estimate or to give a decimal approximation, this would be our final answer. That's it for the quadratic formula. So we have two different ways we can solve. If it's factorable, we can use the zero factor law. If it's not factorable, we can use a quadratic formula. Now let's go ahead and talk about an application. So we're going to find two positive integers whose sum is 21 and whose product is 104. Now we need two numbers because we want to find two positive numbers. So we're going to let be the smaller number, smaller positive number. All right, this is a little better. Whee. And we'll let y be the larger one. All right, now let's go ahead and translate what we have. We know that the sum of the two numbers is 21 and the product is going to be 104. So we know that x plus y is going to be 21, and we also know that x times y is 104. Now we want to be able to solve essentially this system. Well, I can use substitution for this. I'm going to go ahead and say, well, y is going to be equal to 21 minus x. Then I'm going to replace this expression into the product. So x times 21 minus x must equal 104. We'll then get 21x minus x squared equals 104. At this point, we would want to put everything on one side. If I move the 21x and the negative x squared to the other side with the 104, we're going to get 0 equals x squared minus 21x plus 104. At this point, we could either use the quadratic formula, or if it's factorable, we could factor. Now I know that 8 plus 13 is 21. That also means that negative 1, or negative 8, and negative 13 is 21. Now negative 8 times negative 13 is equal to 104. So the factorization would be x minus 8, x minus 13 equals 0. Now that implies, using the zero factor law, that x equals 8 and x equals 13. Now there are two numbers here. In reality, what we found was actually x and y. However, we always want to make sure that we double check our answers to make sure that they're right. Because we want x to be the smaller of the two, as we stated here, we'll go ahead and say that x is supposed to be 8 and that y is 13. But it's important to also talk about the fact that we have positive numbers. it's possible that in applications you could get a positive and a negative number for your variable x. If that's the case, you want to go back to the original problem and say, okay, are we looking for positive or negative? So if we had a positive 8 and a negative 13, x would definitely have to be 8 because 13 would have been negative. There are the numbers.